Okay, 2.4, differentiability and continuity. Okay, the definition of differentiability. The derivative exists for each point in the domain. Okay, when you're differentiating something, you are taking the derivative of something. So differentiability is the ability to take the derivative of something at each point. Okay, a graph is not differentiable if the derivative does not exist for each point in its domain. So we're going to think about a graph and how you can tell from a graph if the function is differentiable or not. Okay, so the derivative does not exist if the function has first a discontinuity. Okay, so a discontinuity, it could be a hole, a jump, or an vertical asymptote, etc. Okay, so let's consider a hole. If there was a hole, something like that, the derivative doesn't exist at the hole because there's no point at the hole for the derivative to exist at. So if there's a discontinuity there, the derivative fails to exist and this function would not be differentiable. Okay, the other situation where it is not differentiable is a corner or a cusp. A corner looks like this. Okay, and then at that corner right there, the derivative does not exist because if I approach from the left, the derivative is negative. If I approach from the right, the derivative is positive. So if you're at this exact point, what is the derivative there? Is it the negative slope? Is it the positive slope? It's not zero because it's pointy. So it's unclear. So it does not exist. The other thing is a cusp. A cusp is when two curves, when there's a curve meeting a curve. So something like that. Okay, and again at this point right here, the derivative or the slope on the left is coming down like this. It's probably going to it's definitely negative, probably negative infinity. In this direction, it's going towards positive infinity. Since the slope on the left and right do not match, the function is not differentiable because of that point, or it's not differentiable at that point. The other situation where it is not differentiable is if there is a vertical tangent. So let's draw a graph with a vertical tangent. Okay. If I try to find a point where there's a vertical tangent, like say there, the slope here, since it's vertical, is undefined, which means the derivative is undefined because the slope is undefined. Okay, so those are the three things you're going to look for on a graph. They ask you about the differentiability of the graph. Okay, so for the example, let's identify the points where the graph is not continuous and then also definite where the graph is not differentiable. So not continuous could be a hole, a jump, anything where there's a gap in the graph. So let's see, going here. Oh, at x equals -3, there's a hole. Okay, let's keep going. Continuous is connected. Connected. When I get to x equals 4, I'm going to jump up. So at x equals 4, there's a jump. And then this graph continues all the way through there. Okay, now if it's not differentiable, there should be more points. Okay, so let me follow this graph and see where it is not differentiable. Okay, since there's a hole, it is not differentiable. So all the not continuous points should be included in the not differentiable. Okay, oh, right here, at x equals -2, there's a cusp. So it's not differentiable. It is continuous because I can draw without picking my pencil. What about here? Now this is fine. The derivative here is 0 because the tangent line has a slope of 0. So this is differentiable. I can tell you it's 0. Okay, at x equals 2, there's another cusp. At x equals 4, there's a discontinuity. And then from there, it continues with actually a constant slope or a constant derivative. Okay, last theorem. If a function is differentiable at x equals a, then the function is continuous at x equals a. This is always going to be true because for something to be differentiable, it has to be continuous. Okay, so it's differentiable here, it has to be continuous. Differentiable here, has to be continuous. The converse is not true. A continuous function is not necessarily differentiable, and that's because you could have something like this. This is continuous, but it is not differentiable at this point. Okay, so differentiability implies continuity, but the converse is not true. Just because it's continuous does not necessarily mean it is differentiable.